4.6 are on modeling with trigonometric functions. So how can we take trig functions and model everyday situations? And trigonometry is something that you will see in many real life applications. So here's a first example right here. The tides at Cape Capstan, New Brunswick change the depth of the water in the harbor. So on one day in October, the tides have a high of approximately 10 meters at 2 p.m. So we've got a high point of approximately 10 meters at 2 p.m. and a low point of approximately 1.2 meters at 8:15 p.m. So here's an example of a sinusoidal function. We've got our tides, and our tides are increasing and decreasing. So here is a perfect example of a model that we can use for a trigonometric function. Okay, so then it says a particular sailboat has a draft of 2 meters. Well, what does that mean? This means it can only move in water that is at least 2 meters deep. If it's less than 2 meters deep, the sailboat can't move. So the captain of the sailboat plans to exit the harbor at 6:30 p.m. Can he safely exit the harbor? So let's see if he can or not. So let's go ahead and first of all, the first thing I want to do is draw a sketch of what's happening here. So I know that I've got a height of my tide, okay, and I also know that I have the amount of time right here. So I'm going to label this right here time because that's my independent variable, and I'm going to label this height, so it's my h of t, okay? And I know that it starts at 2 p.m. So I'm just going to put 0 here, and then right here I'm just going to say that this is 2 p.m., 3 p.m., 4 p.m., so on and so forth, and I'm going to keep going until I get to a little bit past 8 p.m. because we need 8:15 p.m. right here, okay? So now that I've done that, I'm going to go ahead and figure out what my height is going to be right here. So I know that the maximum is going to be 10 and the minimum is 1.2. So I'm just going to go up by 2's right here. So we'll say 2, 4, 6, 8, 10 right here. And I'm going to graph out my information. So I know that at 2 p.m. we have a height of 10. And I know that at 8:15 p.m. we have a height of 1.2, okay? And I know that my graph is going to look something like this, okay? And it'll continue to go this way. All right, so now that I've done that, and I don't know exactly where it's starting, but I'm just going to draw a sketch of it just to have an idea. So this right here, I could use a sine function or a cosine function to model it. I'm going to use a cosine function because if I have a maximum right here, that's the closest value that I have to my y-axis, and cosine functions usually start at our maximums. Doesn't matter, it's up to you, but I'm going to use cosine for this. So I know that h of t is going to be a times the cosine of k times t minus d plus c, just like we did with our transformations of functions. And we're going to find out all of this information right here. Well, remember, our amplitude is simply the difference between our minimum and our maximum divided by 2. So I can say my amplitude is my max minus my min cut in half. Okay, so my amplitude is going to be the maximum is 10, the minimum is 1.2, divide that by 2, I end up getting right here, I end up getting 8.8 divided by 2, which is going to give me 4.4. So I know my amplitude is going to be 4.4. Okay, the next thing I'm going to find out is my C value. So to find the C, instead of doing the max minus the min, we're going to take the max and the min, we're going to add them together and divide that by 2 because we're going to find the average. So the max is 10, the min is 1.2, divide that by 2, I get 11.2 divided by 2, which is 5.6. Now let's see if this makes sense. If I take 5.6, which is going to be my my axis right here, okay, so I know that this is going to be my middle point of my graph. If I add 4.4 to it, I definitely get my height of 10, my maximum of 10, and if I subtract 4.4 from it, I will definitely get my minimum of 1.2. So those values there, I verified, are correct for me, okay? Okay, so now I need to figure out the k value, but to figure out the k value, I need to know the period. Well, how do I find the period? Well, I know that it reaches its maximum at 2 o'clock, and then it reaches its minimum at 8:15. and that's half of a cycle. So between 2 o'clock and 8:15, we know that 6 hours and 15 minutes have gone by. But in order for me to complete a full cycle, I need another 6 hours and 15 minutes. So I know that my period is 12 hours and 30 minutes, or 12.5 hours. Okay, but to find my k value, remember the period is equal to 2 pi over k. So I'm going to say 12.5 is equal to 2 pi over k, and then to solve for k, I get 12.5k equals 2 pi. Bring this up here, so that means that k equals 2 pi over 12.5. But I don't want decimals within my fractions, so I'm going to multiply by 2 over 2. So I know that my k value is 4 pi over 25. Okay, so I've got my A, I've got my C, and I've got my K. The last piece of information I need to know is what is my D value? What is my shift? Well, normally the maximum occurs on the y-axis. So this is shifted 2 units to the right, so my D value is 2. So based on that information, I can go ahead and write out my equation right here. So this equation, I can plug in all of my info. So h of t is going to equal, so I know that the A value is 4.4, okay? And then I'm going to do the cosine of K, we know is 4 pi over 25, times T minus, we know that the D value is 2, okay? And then plus 5.6, because we know that the C value is 5.6. So we're just plugging in all of this information right here. All right, last thing that we need to do now that we've gotten our equation right here is we need to figure out, well, will he be able to sail his sailboat or exit the harbor at 6:30 p.m. safely? Can he safely exit at 6:30? So if I want to know that information, that means that my T value is going to be 6.5. So I'm going to figure out what H of 6.5 is. So all I'm going to do is just plug in 6.5. So I get 4.4 times the cosine of 4 pi over 25 times, when I plug 6.5 in here and I subtract 2, I get 4.5. And then I just add 5.6 onto that. And then when I plug that into my calculator, making sure that I am in radian mode, so go ahead and do that, please, and then come back to me to see if you get the same answer that I do. So you should get h of 6.5 is approximately 2.80 meters. So the question is, can he safely exit the harbor? He definitely can, because in order for him to be able to sail his boat, there needs to be a draft of at least 2 meters, and the water level will be 2.8 meters, so it's high enough. So we can say, yes, he can safely exit because 2.8 is greater than 2.0 meters. So we're good to go for question number 1. All right, number 2, the following table shows the average monthly means of the daily 24-hour temperatures in Hamilton, Ontario. Each month's average temperature is represented by the day in the middle of the month. So question A says to plot the temperature data for Hamilton and fit a sinusoidal curve to the points. So if you notice right here, we've got day of the year, so this is going to be my x values. These are my x values. And then the temperature in degrees Celsius are going to be my y values. And we've got some negatives and some positives for our y values right here. So I'm going to place, since my negative values aren't that low, I'm going to place my x-axis somewhere over here. And I'm going to label this my days of the year. So these are days of the year, okay? And then for my y-axis right here, I'm going to have it go like this. But we got to make sure that we have an arrow on both ends of our y-axis because we can have positive and negative values for our temperature. And we are going to label this right here the temperature. Okay, so we know it's going to go from 0 to 350, so I'm going to go on my graph right here, I'm going to just go by 25s. So 0, and then right here I'm going to say that here is 100, and then I've got 200 days, 300 days, so on and so forth. And then for my x and for my y-axis, we know that our minimum is negative 4.8 and our maximum is 21.9. So I'm going to, I think, go by twos. So 2, 4, 6, 8, 10. We'll put 10 here, 2, 4, 6, 8, 10. We'll put 20 here, and then we'll just say that this right here is negative 6. Okay, so let's go ahead and plot our points. So we know that at 15 days, the temperature was negative 4.8. So I'm going to put a dot right here. At 45 days, the temperature was also negative 4.8. At 75 days, the temperature was negative 0.2. At 106 days, we had a temperature of 6.6. At 136 days, we had a temperature of 12.7. Okay, and you guys don't need to watch me put all of these values, these data points. So go ahead and finish the data points, press pause, finish the data points, and then come back to me so we can talk about how to fit a sinusoidal curve to the points. Okay? So these are where the data should line up. So let's go ahead and connect our points and see what we end up getting. So it's very clear that this has a sinusoidal shape to it. Okay, so now that I've done that, we need to actually find our equation for a sinusoidal curve. So we know that we can say y equals a sine of k times t minus d plus c, and we're going to find out all of our information. So to find the amplitude, just like we did before, we'll take our max, subtract our min from it, divide it by 2. When we know our maximum occurs at 21.9, so we're going to say 21.9, okay? And we know our minimum occurs at negative 4.8. So negative 21.9 minus negative 4.8, divide that by 2. Remember, this minus a negative turns into a positive, so I get 26.7 divided by 2, which is 13.35. Okay, now I'm going to find the C value, and to find the C is the same idea, but I'm going to do the max plus the min, divide that by 2. So I'm going to take 21.9 plus 4.8, divide that by 2. I end up getting 21.9 plus negative 4.8. So I'm going to subtract those values. So I end up getting 17.1 over 2, which is 8.55. Let's verify that this makes sense. So if 8.55 right here is my minimum value, so it should, or sorry, my axis value right here, this makes sense. This is right in the middle. And then if I add 13.55 to it, I do end up getting the 21.9. And if I subtract 13.55 from it, I do end up getting the, sorry, not over here. That doesn't make sense. Over here, when I subtract 13.55 from it, I end up getting the negative 4.8 that I'm looking for. Okay, great. So now let's talk about our period. Well, our period, we're talking about a whole year. So our period is 365 days. So we can say our period is equal to 2 pi over k. Okay, so then when I want to solve for k, I just end up getting 365k equals 2 pi. So therefore, k equals 2 pi over 365, okay? And then the last thing I need to do is figure out what my d value is. Well, my d value will occur on my axis right here. So I know my axis will occur right here, and it's about right here, it's about 116 days right here. So we can say that our d value right here is 116. So based on that information, I can fit all of that information in, and I can get my equation. So the a is 13.35 times the sine of the k value we figured out is 2 pi over 365 times our time minus our d value, which is 116, and then we can just add our 8.55, and that's our equation right here of our graph. That's our information, okay? And then lastly, question B says, estimate the average daily temperature in Hamilton on the 200th day. So I can say T equals 200. So that's what I'll do. I'll say y equals 13.35 times the sine of 2 pi over 365 times, when I plug in 200 right here, 200 minus 116 is going to be 84. okay, plus 8.55. Okay, plug that into your calculator, press pause and plug it into your calculator, see what you end up getting, and then come back to me to see if you agree. Make sure you're in radian mode for this to work. So you should get approximately 21.8 degrees Celsius. Okay, so then when I look right here, does that make sense? At 200 days, would I have 21.8 degrees Celsius? Definitely, because 200 occurs between 197 and 228, closer, way closer to 197, and 21.8 is very close to 21.9, so the answer does make sense. And we are good to go for this lesson. All right, see you later.